Morning. Let us start with the 7th unit of the 11th class, that is chemical equilibrium. This is lecture number 1. First state question is define equilibrium. Equilibrium, it is defined as that state of a system at which its rate of two opposing processes they become equal. So suppose we are having a crowd in the temple, 10 people they are in the temple, 10 fresh people come in the temple, and these 10 old people they go out of the temple. So that will be a state of equilibrium when forward and backward rate they become equal. So that is the state of equilibrium. We take the example of seesaw. When both the leaves of that your swing they are in the center, that is called the state of equilibrium. Now we come to the chemical equilibrium. Define chemical equilibrium. Now, an equilibrium obtained in case of the reversible chemical reaction when it is brought in a closed system, that state of the system is called as chemical equilibrium. It can be done only in a closed system. For example, we have number of such reactions. CaCO3 solid, when it is heated and in a closed system, will be a state when the rate of decomposition of CaCO3 will become equal to the rate of reformation of CaCO3 from CaO plus CO2. That will be the point of equilibrium. Similarly, we have H2 gas which combine with I2 gas to give you 2Hi. So this is the point of equilibrium. Chemical equilibrium can be demonstrated graphically. Initially we have the reactants. With the passage of time the products are also forming. This is the point of equilibrium. Initially we were having CaCO3 solid. When it start decomposing into CaO plus CO2, they start reforming CaCO3. So initially the concentration was very less. With the passage of time it increases. Therefore, after some time there will be a state of equilibrium between CaO and CO2. So this will be the concentration of the reactant or product. This is called as progress of reaction. This point represents state of equilibrium. Then third question we have defined physical equilibrium. So equilibrium obtained in case of the physical reversible reaction when it is done in a closed system, that equilibrium is called as physical equilibrium. For example, we are keeping a ice H2O solid in contact with water in a thermos flask. So in thermos flask, what is the amount of ice melting? That will become equal to the amount of ice formed from water through the solidification. So this is the state of equilibrium when rate of melting of ice that becomes equal to the rate of formation of ice in the closed system. This will be called as the state of physical equilibrium. It is again obtainable only in the closed system. Then from physical equilibrium we got the idea regarding melting point of the solids. So it is the temperature at which the solid just start changing into liquid. and within 1 degree whole of the solid that will melt, that will change into the liquid. This is called as the melting point. It is for crystalline solids only, it is not for amorphous solids. Then we have freezing point. We got idea regarding freezing point of the liquid. So it is the temperature at which solid just starts forming from the liquid, and within 1 degree or 2 degree it will completely change into solid. So freezing point is the temperature at which the solid just starts separating from the liquid, or it is the temperature at which the vapor pressure of the liquid phase of a substance become equal to the vapor pressure of the solid phase. This temperature is called as the freezing point of that solution or that liquid. Then we have saturated solution. Saturated solution, it is that state of the solution at which maximum solid is dissolved in the liquid. Beyond that, no further solid can be dissolved in the liquid by either by increasing temperature or by decreasing temperature or changing the pressure above the solution. No more solid is dissolved in the liquid. This state of the solution is called as saturated state because it has a maximum dissolved solid in it. What was its capacity to dissolve the solid? It has dissolved according to that capacity, and beyond this point no more solid can be dissolved in the solution. That is saturated state. If at this state of the solution we add some solid and we shake well, then this solid might dissolve in the liquid, but equal amount of solid that will come out of the solution. So this is your saturated state at which if solid is dissolved, the same amount of solid that will come out of the solution, that is the saturated state. Then we have what is Henry's law. Henry's law, it states that the mass of a gas dissolved in a liquid is directly proportional to its pressure above the surface of the liquid. Higher the pressure of the gas on the surface of the liquid, more will be its solubility in the liquid. So mass of gas dissolved is directly proportional to pressure of the gas above the surface of the liquid, removing sign of proportionality by another constant. This is called as Henry's constant. Sometimes it is also represented by Kh. So higher the pressure of the gas, higher will be the solubility of gas in the liquid, or we can also calculate Henry's constant. This is also equal to Kh is equal to m upon. That is mass of the gas inversely divided by pressure, it will give you Henry's constant. Why equilibrium is dynamic in nature? Why it is said? Why equilibrium is dynamic in nature? Equilibrium is said to be dynamic because it always involves two opposite reactions. One is forward reaction, another is backward reaction, and their rates are equal at equilibrium point. So it is said to be dynamic in nature because it is not involving only one reaction, it is involving both the reactions, it is involving forward as well as backward reaction. That's why it is said to be dynamic in nature. Then we have the next question. What are reversible? Reactions. Reversible reactions are those reactions where products of the reactions they are capable of reforming the reactants. So when the products are capable of reforming reactant, these reactions they are called as reversible reactions, and condition is they should be carried out in the closed system. These are reversible reactions. CaCO3 decomposition of CaCO3 we considered earlier. closed system. Similarly, formation of HI from H2 and I2. These are the reversible reactions. Then we come to next question, what are irreversible reactions? That will be question number 10. Can we attain equilibrium in the irreversible reactions? No, because the products do not have the tendency to recombine to give back the reactant. So our question number 10, define irreversible reactions. So irreversible reactions are those reactions which proceed only in one direction. They proceed only in one direction. Example is C solid combines with O2S to give you CO2S. Delta H in this case is 393.5 kJ. They are called as irreversible reactions. So they proceed only in one direction. Similarly, we have combustion of methane. Delta H is 890.3 kilojoule per mole. So these are irreversible reactions. They cannot be brought to the equilibrium state since products have no tendency to reform the reactants. Now, what are the characteristics of chemical equilibrium? Physical and chemical equilibrium. First of all, both should be brought in a closed system. If system is open, then one of the reactant or product or all the reactant or product, they will escape from the system. Then equilibrium cannot be obtained at all. Secondly, equilibrium is always dynamic. Two reactions take place, forward as well as backward reaction, and their rates are equal. So equilibrium, whether it is physical or chemical, it is always dynamic in nature. Third is there is no change in macroscopic properties of the equilibrium, like color, pressure, temperature, etc. They do not change during the state of equilibrium. If they will change, the state of equilibrium is likely to be disturbed. Then they are not affected by catalyst. The catalyst only reduces the time to attain state of equilibrium. It affects both the reactions at equal extent. जितना फॉरवर्ड रिएक्शन के रेट को इंक्रीज करेगा उतना ही बैकवर्ड रिएक्शन के रेट को इंक्रीज करेगा. So it affects both of the reactions to equal extent. Number 5 we have, it can be achieved from any side, starting with reactant or starting with product. It can be achieved from any side. Whether you start the reaction from the reactants, you will come to the equilibrium state. Similarly, if you start the reaction with the product, you will again come to the state of equilibrium. Then we come to the next topic, that is what is law of mass action. We'll discuss it in our next lecture.